One of the first new things we do in grade 11 analytical geometry is the equation of a straight line. So we've done obviously equation of a straight line since grade 9, where we have y equal to mx plus c, where m is your gradient, your change in y over your change in x. And then with change in y and change in x, this is usually in analytical geometry the formula we use, or just straight up when we want to find, because straight line is like the one function that you will get in paper 1 and you will get in paper 2 at the end of the year, that is, now once you've done the work, because it's both in our functions chapter and in our analytical geometry chapter. So this is your formula. It doesn't matter which one is point 1 and which one is point 2. The important part is that a pair of coordinates goes together and together, and then like on top of one another. And then also, so far what you've done in maths, this is the only place where y is before x, where it's not alphabetical. Okay, just keep that in mind. Then you've also done a horizontal line and a vertical line. A horizontal line is not that tricky, because usually if you do have 2 points, then you'll just find your gradient is 0 and then do your substitution. But a vertical line is quite tricky. So a horizontal line is the one that only goes through the y-axis, okay, which is y. It's whatever y value it goes through, y equal to that value, and it's going to be parallel to the x-axis and perpendicular to the y-axis. Similarly, vertical line is going to be x equal to whatever that x value is that it's going through. It will be parallel to the y-axis and perpendicular to the x-axis. And then this can also come into play with like making right angle triangles or quads and whatever. Then the new part, because this is old news, boring anyway. The new part is gradient point formula, and you're never forced to use this, but I do think it helps, and it opens up a new way of finding, and it's slightly easier. But I know like some people are stuck in their ways, and by some people I mean when I was in school, I literally refused to use this formula because this was comfortable and this was like what I knew. But this is actually easier. It's like here you would have 2 steps. You would find your gradient, you would find the gradient, substitute in, and then find your c, and then go put it back in. This does everything once you have your gradient and your point one time. Go on with your life. Okay, and we're going to discuss this on the next slide. But basically, there's where you substitute whatever point you have, and then that is your gradient. Okay, let's determine the equation of a straight line that is parallel to this line. Okay, it's not this line, but it's parallel to that. When you see parallel, you need to know gradients are the same. So this will also be your gradient passing through that point. So you have a gradient and you have a point. That is what you need for a straight line. You either need a gradient and a point, or you need 2 points, because with 2 points you can find a gradient. So this is our new formula. And what you can do here is you can substitute your gradient, which is 2, and you can substitute your coordinates. So your coordinate is 1, -4, and your gradient is 2, and then you just multiply out. So this is y plus 4 equal to 2x. Remember, this 2 gets multiplied with both terms, so -2. You take the plus 4 over by subtracting 4, and then you're going to have 2x minus 6. And you see here now, one shot, you already have your equation. You don't have to go substitute back in once you have your c. But again, they can't really force you to use this. It's just a nice like tool to have in your pocket also. Then here again, determine the equation of the straight lines passing through these 2 points, the pair of points. So again, to find a straight line, we need a gradient and we need a point. We don't have a gradient, but you can find it if you have 2 points, which you do have. Okay, so you can find your gradient. Remember, it doesn't matter which pair is in front, as long as they're on top of one another, they are together with the y on top, of course. And then you should be getting 2. Now you have a gradient. You choose which point you want to use. I would usually use the point that doesn't have a minus, just because then you're a bit more safe with like sign changes and whatever, but it doesn't matter, you're supposed to get the same answer. So you can substitute everything into your formula, then this would multiply out to 2x minus 2, the same as it was here, and then I would already sort of take over the minus 9 by adding 9, and then you have 2x plus 7. And then C, you'll see I made a very, very small space for you to write this answer. Another reason for that. You can go do all the work if you want to. You're very welcome to quickly pause and do so. I'm not going to do that because I want you to see something here. Okay. If you tried to do this yourself, you would have probably like been a bit shocked because you would have found that you're dividing by 0 when you put it into the gradient formula. And now you're like, what now? You need to know if your gradient is undefined. That means it's either horizontal or vertical, and then you need to think carefully. It's the vertical line, the one that only goes through the x-axis. And a quicker way you could have seen this is a straight line. So points are not supposed, it's not like a parabola where you can have two of the same y values. Okay, and we get to, you can get same x values later on. But anyway, you saw the two x values are the same. So the x is equal to -2. Clap. Okay, a straight line. If 2 points have the same either x value or y value, it means it's going to be x equal to that if it's an x value, or y equal to that if it's a y value.